With question 8 here, it's actually a functions and applied measure question. So here we have a square sheet of cardboard of side 10 units is made to open a box. So square side of x units used where x is an element of the rail are removed from each corner of the cardboard, and it is then folded along the dotted lines as shown in the diagram. So here you can see it's 10 across, but they've removed x on each side. So find the length, breadth and height of the box as shown in the diagram above. Well, first of all, it's a square, so you've got the length and the width, doesn't matter which side is which. So the length and breadth, or length and width, are going to be the same. So it was originally 10, but then they took away x on each side, so it's 10 take away 2x. So that's 10 take away 2x for the length, and the width, same thing. The height then is just x, because that's the little bit that's removed on each side. So that question there is worth 5 marks. For part B then, they're asking you to show that the volume of the box is 4x cubed minus 40x squared plus 100x. So we knew that the volume is length by width by height. So we can sub that in. So the length was 10 minus 2x, and the width was 10 minus 2x, and the height was x. So if we start off by multiplying the first two brackets, so 10 by 10 is 100, 10 by minus 2x is minus 20x, minus 2x by 10 is minus 20x, and then minus 2x by minus 2x is plus 4x squared. So we still need to multiply each term by x. If you didn't realise that by now, you could have just simplified it, and you would have had 100 minus 40x plus 40x squared, and notice that you're just missing an x on each one. So that's what we're going to do here. So 100 by x is 100x. This is minus 40, so that gives you minus 40x squared, and 4x squared is now 4x cubed. So it's the same answer there, just written slightly different. So for that question there, it is worth 10 marks. For part C, you're asked to explain why a box of height 6 units cannot be used for the cardboard. Well, if we start subbing that in for 10 minus 2x, so the length is 10 minus 2x, and we're saying x is 6. Well, that would give us 10 minus 12, which is minus 2. And the width would also be minus 2. And the height is 6. So if you do length by width by height, you'd get minus 2 by minus 2, which is 4. 4 times 6 is 24. Now that works, but you can't have minus 2 cannot be a dimension, meaning you can't have minus 2 as a length or a width. So that's why that wouldn't work. So that is 5 marks. For part D then, you're just putting them into your table. So if you go to your calculator and press menu or mode and go 3 for table, you want to put in your function of 4x cubed, just press alpha and then the bracket button for x, put in the cubed, and then put in minus 40, alpha again, x, put in the squared, plus 100, alpha and then x. You will be asked what is your start. Your start is 0. You'll be asked what is your end, which is 5. Which is the same as here and here. So start and end sometimes is given to you as a domain in the question, sometimes it's given to you in the table. Now it's going to ask you for steps. Your steps here are 0.5 because you can see they're going up in 0.5 increments. If you're on the new calculator and it comes up with g of x, just skip it and press equals. So you have all your values here. So 0 gives you a value of 0. 1 gives you a value of 64, 1.5 gives you 73.5, 2 gives you 72, and I'm just getting those values by going down on the table in my calculator. 2.5 gives you 62.5, 3 gives you 48, 3.5 gives you 31.5, 4 gives you 16, 4.5 gives you 4.5, and 5 gives you 0. So that gives you 20 marks between the table and actually graphing them. So what we're going to do now is plot them. So 0, 0, remember 0.5 is around 40.5, 1 is at 64, 1.5 is at 73.5, 2 is at 72, 2.5 is at 62.5, 3 is 48, 3.5 is 31.5, and then 4 is 16, and then 4.5 is at 4.5, and 5 goes back to 0. So just make sure that you actually just join them all up together. So we just use freehand and we just join them all up together. And that's your curve. So 20 marks for those two parts. Now for part F, it's asking you to use your graph to find the maximum volume of the box, which is just the top part of your graph. So if I go across and see what the top part, so that wasn't very good there, so I'm going to go again and actually start from the graph itself, and see that that's the highest point, and then I just draw a dotted line. So that's a little bit under half, so I would say 74 would be the units there. They're asking for the values of x, which create a box which has a volume of 30. So this is your volume here on your y-axis. So I go to 30 here, I go down to my x-axis, and then I go to the other 30, and again go down to my x-axis. So I've got two values here. So I would say 0.3 maybe, or 0.4, and then the next one would be around 3.5 for me. Some of you might get a little bit different. And then the volume of the box when x is 2.8. So I go to where 2.8 is on my graph, and I go use a ruler and use try and be as accurate as you can, and go across. And I can see that's halfway between 50 and 60, so I would say around 55. They do allow a little bit of free numbers on each side, so like a percentage error, so 1 or 2 units on each side. Okay,